Everybody. Today we are going to discuss about the synthesis of carboxylic acid under the topic carboxylic acid. So we have already seen that what are the carboxylic acid. We have seen the structure of carboxylic acid. We have seen the effect of inductive effect and other structures of carboxylic acid, how this inductive effect and other things will affect the acidity and thing. Now we will see what are the various methods for the synthesis of carboxylic acid.
Subscribe to GPR Chem World, and don't forget to click the bell
So
icon.
usually carboxylic acids are synthesized via various chemical methods. Among the first and important method is the oxidation of primary alcohols to carboxylic acids. So in the synthesis of carboxylic acids, require the incorporation of the carboxylic group in the substrate. So introduction of carboxylic acid is very important. So in alcohol, when alcohol are undergo oxidation with oxidizing agent, they will convert into carboxylic acids. So there are various carboxylic acids can be prepared, or primary alcohols can be converted into corresponding carboxylic acid via oxidation method by using various oxidizing agents such as chromic acid CrO3, sodium chromate, potassium chromate, or potassium permanganate. However, it is found that the primary alcohol are very acidic. With acidic acid is unusually formed the ester also. So there is a drawback that when acidic chromic acid has been used, primary alcohol will, after the formation of acid, they will undergo the esterification. So it is a second reaction is possible. Now, if you see the primary alcohol oxidation, when alcohol undergo oxidation with KMnO4 in presence of potassium hydroxide as a base, the potassium carboxylate salt is formed, which on under acidification will lead to the formation of carboxylic acid. The example of is here the cyclohexyl methanol will undergo the potassium permanganate oxidation with KMnO4 water. It is called aqueous KOH. First, the potassium cyclohexyl carboxylate salt will form, which will undergo hydrolysis to give the cyclohexane carboxylic acid. Now, the second method for the preparation of carboxylic acid is the oxidation of corresponding aldehyde. So when aldehyde undergo oxidation with oxidizing agent, they will convert into the carboxylic acids. So aldehydes with both strong as well as mild oxidizing agent will convert into the corresponding carboxylic acid. So the main oxidizing agent used are chromic acid, which is oxidation in water or dilute mineral acid conditions. The sodium chromate or potassium chromate, it is undergo oxidation in dilute mineral acids. KMnO4 oxidation, which is a basic media in the presence of potassium hydroxide, or very mild oxidizing agents like silver oxide also undergo the oxidation, but very important that in silver oxide there is no oxidation of alcohol will take place. That's why it is a very selective reaction for the oxidation of aldehyde into carboxylic acid where alcoholic group is present. Now if you see the example of this cyclohexyl aldehyde KMnO4 sodium hydroxide water, it is a aqueous basic condition with potassium permanganate oxidizing agent. The salt will form, which will undergo hydrolysis to give the corresponding cyclohexyl carboxylic acid. In some of the aldehyde cases, there will be some other oxidizing agents such as alkene, etc. will be there. In that case, the mild oxidizing agents like silver oxide is being used. So where these other oxidizable groups such as alkene or any other alcohol will not undergo the oxidation. Now, the another method for the synthesis of carboxylic acid is the reaction of alkene with ozone followed by the oxidation with hydrogen peroxide. This is called ozonolysis of alkene. So the carboxylic acid can be prepared from the alkene via the ozonolysis method. In this ozonolysis, the alkene will undergo oxidative cleavage via the use of hydrogen peroxide, which is the oxidizing agent, and then corresponding carboxylic acid will be formed. So mostly in this case, dicarboxylic acid or two molecules of carboxylic acid will form. If it is a open chain alkene is there, two carboxylic acid will form. If it is a cyclohexene is there, in that case, dicarboxylic acid, that is hexane dioic acid, which is called adipic acid, will form. Now, ozonolysis of alkynes. So, alkyne also undergo the ozonolysis followed by the hydrolysis, give the carboxylic acid. So, in ozonolysis, what happened? There is two formulas. For example, one octane will undergo the ozonolysis and form the carboxylic acid. One is eptanoic acid and formic acid. So, if it is a terminal alkene, the formic acid will form selectively, which is a confirmation of oxidation as the alkyne group. The example, cyclohexyl acetylene will undergo ozonolysis followed by hydrolysis, will give a cyclohexane carboxylic acid and formic acid as a product. Now, if you see the carboxylation of Grignard reaction, the next method for the preparation of carboxylic acid is the carboxylation reaction, where alkyl halides will undergo reaction with magnesium and form the Grignard reagent. This Grignard reagent will undergo reaction with carbon dioxide and followed by the hydrolysis to give the carboxylic acid. So, in this reaction, the carbon dioxide will inserted into the reaction and CRBr, alkyl bromide, will undergo carboxylation. So, the overall reaction is a first formation of the Grignard reagent followed by the carbon dioxide insertion, then hydrolysis of this product will take place and carboxylic acid will take place. If you see the reaction of Grignard reaction with carbon dioxide, it is the addition reaction at one of the carbon oxygen double bond, and we will get a carboxylate salt of magnesium. This is further undergo hydrolysis as it is a salt. It will undergo hydrolysis and will give the carboxylic acid as a product. Now, if you see another example of carboxylation of Grignard reaction, both aliphatic and aromatic carboxylic acids can be prepared by carboxylation of Grignard reaction. So, this reaction is a general reaction where aliphatic as well as aromatic carboxylic acid can be prepared from corresponding Grignard reagents, which in turn can be prepared from the corresponding alkyl halides. These alkyl halides can be prepared from corresponding alcohol. So, the first example where alcohol isobutyl alcohol will reacted with PBr3 to undergo the nucleophilic substitution reaction where alkyl secondary bromide is formed. This will undergo reaction with Grignard to give the 2-butyl magnesium chloride as a Grignard reagent. This Grignard reagent undergo the carbon dioxide carboxylation, then followed by the hydrolysis to give the corresponding carboxylic acid, that is 2-methyl butanoic acid in 76%. In the second key equation, the phenyl bromide or bromobenzene is reacted with magnesium to give the phenyl magnesium bromide. This will undergo the carboxylation with carbon dioxide to give the corresponding salt of magnesium, which will undergo hydrolysis to give the benzoic acid as a product. Now, the next method for the preparation of carboxylic acid is a hydrolysis of nitrile. So, when nitriles undergo hydrolysis under the acidic condition, or it can get acid catalyzed hydrolysis of nitriles, will give the carboxylic acid as a product. So, in this case, the nitrile group is undergo hydrolysis and ammonia gas or ammonium ion will form. So, most of the aliphatic nitriles are obtained by a nucleophilic substitution reaction from alkyl halides with cyanides. So, this is a very important reaction where the hydrolysis can be, carboxylic acid can be prepared from the alkyl halides via the cyanide reactions. The example is given. 1,3-dibromo-propane will undergo reaction with sodium cyanide. It will give pentane dinitrile. This pentane dinitrile will undergo hydrolysis under acidic condition in presence of HCl to give the corresponding dicarboxylic acid, which is called glutaric acid or pentane dioic acid. Now, there is a side chain reaction. When benzene has alkyl group at the side chain, it will undergo oxidation in presence of a strong oxidizing agent like chromic acid, potassium permanganate, hydrolysis. It will give the corresponding carboxylic acid, where the carboxylic acid group will generate as the benzylic carbon, which is attached to aromatic ring. So the example is that 1,2-dimethyl benzene will undergo chromic acid oxidation in sulfuric acid, give the 1,2-dicarboxylic benzene. Whereas this ditetrahydronaphthalene will undergo oxidation with chromium trioxide. It will also give the 1,2-dicarboxylic benzene dicarboxylic acid. With this, we have completed today the synthesis of benzoic acid, and in next class, we will see about the physical properties, chemical properties, and the reactions of carboxylic acid. Thank you. Good.